Hello guys, welcome back to our channel. In this video, we will solve a problem from chapter 11, which is still the heat transfer. So here we have a problem. Determine the total rate of heat transfer from a spherical ball whose surface is maintained at a temperature of 70 degrees Celsius and is suspended in the middle of a room at 20 degrees Celsius. It has a diameter of 5 cm and the convection heat transfer coefficient is 15 watts per square meter per degree Celsius. So in the problem, a spherical ball whose surface is maintained at a temperature of 70 degrees Celsius is suspended in the middle of a room at 20 degrees Celsius. So the total rate of heat transfer from the ball is to be determined. So our assumption in this problem is that the steady operating conditions exist since the ball surface and the surrounding air and surfaces remain at constant temperatures. And the thermal properties of the ball and the convection heat transfer coefficient are constant and uniform. So our properties here is the emissivity of the ball surface is given to be 0.8. So our analysis is that the heat transfer surface area is equal to pi d squared. So as you can see, this is our figure, and this is our spherical ball having a diameter of 5 cm, and this 5 cm here should be converted into meter, and we get 0.5 meter. And our air temperature is 20 degrees Celsius, and the ball is 70 degrees Celsius. So we are going to determine the total heat transfer of this spherical ball. So for our surface area, again, we have the formula pi d squared. So plugging in the values, we have 3.14 multiplied by 0.05 meter squared. We get 0.007854 square meter. So under steady conditions, the rate of heat of convection and radiation heat transfer are given by this formula. The rate of heat transfer by convection is equal to the heat transfer coefficient multiplied by the surface area multiplied by the change in temperature. So plugging in the values, we have 15 watts per meter degree Celsius multiplied by 0.007854 meter multiplied by 70 minus 20 degrees Celsius. So here, Celsius and meter will be cancelled. So our remaining unit is in watts. So the heat transfer by convection is equal to 5.89 watts. Next, we are going to solve for the heat transfer by radiation, given by the formula. The rate of heat transfer by radiation is equal to the emissivity multiplied by the Boltzmann constant multiplied by the surface area multiplied by the difference between the temperature of the surface and the temperature of the ball. So we have 0.8 multiplied by 0.007854 square meter multiplied by 5.67 times 10 raised to negative 8 watts per square meter per Kelvin raised to 4 multiplied by the quantity of 343 Kelvin raised to 4 minus 293 Kelvin raised to 4. So these values here, we only converted 20 degrees Celsius and 70 degrees Celsius into Kelvin by adding 273. So solving this equation, we get the rate of heat transfer by radiation equal to 2.31 watts. Now, since we already get the rate of heat transfer by convection and by radiation, we can now solve for the total heat transfer, and that is given by this equation, or this formula rather. The total rate of heat transfer is equal to the rate of heat transfer by convection plus the rate of heat transfer by radiation. Putting in the values, we have 5.89 watts plus 2.31 watts, we get 8.20 watts. So this is our final